Very good morning to one and all, and I welcome you all in today's heat transfer lecture. Whether my voice is audible and can you see my presentation? Please comment in the chat box. Okay, great. Okay, so we'll revise some points from the last lecture. In the last lecture, we have discussed about thermodynamics, and we have discussed some basics about the thermodynamics. Okay. So basically, the definition of a thermodynamics tells us that it is science which deals with relation amongst the heat and work and the properties of a system which are in equilibrium, and it will help to describe the state of matter and change in state of physical systems. Okay, so the and we have also discussed the heat transfer definition. You can see that heat transfer definition in the screen also. On the screen also, the transmission of energy from one region to another region as a result of a temperature gradient or a difference. Okay, so in the definition only we can find the difference between the heat transfer and the thermodynamics. Okay, so basically the thermodynamics is dealing with the work and energy and the state of a matter at a equilibrium state. Okay, or we can say that at a equilibrium condition. Okay, so that is the basic difference. We can say that between the heat transfer and the thermodynamics. Whereas the heat transfer required to transfer the heat, it is required there should be a temperature gradient. Okay, or the temperature difference. So if there is a temperature gradient or a temperature difference, so there will not be a equilibrium, the state will be changed, there will not be equilibrium state. Okay, so that we can say that the thermodynamics deals with the equilibrium state, whereas the heat transfer deals with the non-equilibrium state. Thermodynamics deals with the equilibrium state of, whereas the heat transfer deals with the non-equilibrium state. So clear difference between the thermodynamics and the heat transfer I have mentioned over here. Okay, so as we have discussed in the definition, that it deals with, thermodynamic deals with the equilibrium state of matter and not consider the existence of temperature gradient. Okay, thermodynamic does not consider the existence of temperature gradient, whereas the heat transfer is a non-equilibrium process. Since to transfer the heat, the temperature gradient uh, uh, is the most important requirement. Okay, temperature gradient or a temperature difference is the most important requirement to transfer the heat. So heat transfer is a non-equilibrium process, since a temperature gradient must exist for exchange of heat to take place. Now, when system changes from one equilibrium state to another, thermodynamics helps to determine the quantity of work and heat interaction. We have always discussing this point in a thermodynamic, how much energy change or how much heat interaction happen when water boil, or we can say that water change its states from liquid to the ice. Okay, so change of state. Okay, when the state is changed at that time, how much heat is interacted, that we come to know by using the thermodynamics law. But uh, it will not provide the data that how much time is required to change that particular state. Okay, simple language, how much time is required, that will not provided by the thermodynamics. Okay, that will not provided by the thermodynamics. Yes, it tells that how much energy is required to convert the state from liquid to solid, or from solid to liquid, or liquid to gas. Okay, but it will not tell us that how much time required to convert that state. Okay, and uh, so that the heat transfer is dealing with the rate. Heat transfer is always dealing with the rate. Okay. So in heat transfer, we come to know that how much heat transferred per unit time. Okay, how much heat is transferred per unit time, or to convert that particular state of a matter, how much time required. Okay, how much time required. So it helps, also it helps to find out or to predict the distribution of a temperature inside the body. Okay, let us say that we have provided the heat one of the body. Okay, so what will be the temperature on the surface of the body, what will be the temperature at the inner surface of a body, and how it vary as the distance goes on varying from surface to the inner surface. Okay, from surface to the inner surface, so how it will be vary. So that we come to know by using the heat transfer laws, or heat transfer phenomenon. Okay, and it we never seen that whether the variation of a temperature with respect to distance in a thermodynamics. Okay, so the thermodynamics describes how much heat is to be exchanged during a process, but does not hint how the same could be achieved. Okay, how the same could be achieved म्हणजे की काय, कितना टाइम उस प्रोसेस को लगा, ये थर्मोडायनामिक में हमें नहीं मिल सकता. वेयर एज in heat transfer, what rate heat is transferred, that we can easily find out. Okay, that we can easily find out. So that is the basic difference between the thermodynamics and heat transfer. This is the basic difference between thermodynamics and heat transfer. Getting everyone? What is the difference? Okay, first is nothing but thermodynamic is the equilibrium. It deals with the equilibrium state of a matter, whereas the heat transfer is a non-equilibrium process. Okay, and it will tells thermodynamics tells us how much heat energy, or the quantity of work interacted during the change of the state, but it will not tell us that what is the temperature distribution in the body, whereas the heat transfer tells us the distribution of temperature inside the body. It does not tell us that how much time is required to change that particular state, or how much time required to change that particular state, whereas heat transfer provides us the rate of heat transferred. From that rate we can find out how much time required to complete that particular process of a change of a state. Okay, so this is the basic difference between the thermodynamics and heat transfer. Please note down this difference, which will help you to describe the heat transfer and thermodynamics easily, and to determine the basic uh, difference between the thermodynamics and heat transfer. Okay, so write down, make two columns. In first column you put up thermodynamics, and in second column you put up heat transfer. Okay, so first point in a thermodynamics, first point in a thermodynamics, it deals with it deals with it deals with equilibrium state of matter. It deals with equilibrium state of matter. It deals with equilibrium state of matter, and 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 not consider the existence of temperature gradient, and not consider the existence of temperature gradient, existence of temperature gradient. First point in heat transfer, first point in heat transfer, it is non-equilibrium process. It is non-equilibrium process. It is non-equilibrium process since a temperature gradient since a temperature gradient since a temperature gradient must exist must exist since a temperature gradient must exist for exchange of heat for exchange of heat for exchange of heat to take place for exchange of heat to take place. For exchange of heat to take place. Second point in thermodynamics, when system changes when system changes from from one equilibrium state from one equilibrium state when system changes from one equilibrium state to another to another to another comma to another comma thermodynamics helps to determine thermodynamics helps to determine thermodynamics helps to determine helps to determine the quantity of work the quantity of work the quantity of work and and heat interaction the quantity of work and heat interaction, whereas in heat transfer in heat transfer it helps to predict it helps to predict it helps to predict it helps to predict the distribution of temperature the distribution of temperature it helps to predict the distribution of temperature inside the body distribution of temperature inside the body distribution of temperature inside the body. Third point in thermodynamics, it describes how much heat is to be exchanged. It describes how much heat is to be exchanged during a process during a process during a process during a process but does not hint does not hint how the same could be achieved but does not hint how the same could be achieved but does not hint how the same could be achieved how the same could be achieved. Whereas in heat transfer, third point, it provides it provides it provides at what rate it provides at what rate at what rate heat is transferred. It provides at what rate heat is transferred. Okay, getting everyone the basic difference between thermodynamics and heat transfer. If you have any doubt, you can ask. Okay, shall we move ahead to the next point? Please comment in the chat box if you have any doubt, any question. you can unmute and you can ask. Or you can comment in the chat box also that we have cleared the difference between thermodynamics and heat transfer. Please comment in the chat box. The session should be interactive or else. Okay, thank you. Okay, so we are moving towards our main core part now. Okay, so we have discussed that the heat transfer is defined as the transmission of energy from one region to another region as a result of a temperature gradient. And this heat transfer is takes place because of a three modes of a heat transfer. Okay, so this heat transfer is takes place by the three modes of heat transfer. One is nothing but a conduction, second one is nothing but a convection, and third one is nothing but a radiation. Okay, these are the three basic modes of a heat transfer. Okay, so now we try to understand what is meant by conduction. Okay, so conduction means, here I have mentioned that conduction is the transfer of heat from one part of a substance to another part of a substance, or from one substance to another substance in physical contact with it without appreciable displacement of a molecule forming the substance. What it means? Okay, so conduction means what? Whatever the heat is transforming within a substance. Okay, consider any substance and heat is transforming in that from one region of that particular substance to another region of that particular substance only, then that heat transfer will be considered as a conduction. Also, or okay, two different substances are there. Okay, two different substances are there, and that two different substances are in a physical contact. That is nothing but what? That in that two substances surfaces are touching to each other. Okay, that two substances surfaces are touching to each other. That is nothing but what? They are in a physical contact. So in that case, whatever the heat transfer from one substance to another substance will be considered as a conduction. Will be considered as a conduction. So that is nothing but what? Transfer of heat from one part of a substance to another part of a same substance, or the substances which are in physical contact and transfer of heat between that two substances will be considered as a conduction. Will be considered as a conduction. Okay, so take the example of this particular person holding the rod over the burning candle. Okay, so this portion will be hotter. Okay, so this portion will get heated because of this particular fire, and the heat will be transferred from this region of a substance to this region of a substance. Okay, that heat transfer will be considered as a heat transfer from one part of a substance to another part of a substance. Heat transfer from one part of a substance to another part of a substance. Getting everyone? What is meant by heat transfer within a substance? Okay, so one part we have holded over the fire, and that particular part will get heated, and after some time that particular person will feel the heat. Okay, that is nothing but what? This heat is transforming within a substance from one region of a substance to another region of a substance. Okay, from one region of a substance to another region of a substance. Okay, so that will be considered as a conduction. That will be considered as a conduction. Then heat transfer from one substance to another substance which are in a physical contact. Consider that there are two substances. This is the first substance and this is the another substance. First substance having the temperature more than the another substance. Okay, first substance which is shaded by green color, shaded by orange color, and the another substance which is shaded by blue color. Okay, so orange color substance having the temperature more than the blue color substance. Okay, now initially they are apart from each other. Okay, there is no contact between these two substances. Okay, once these two substances are in a physical contact, at that time the orange color substance will transfer the heat to the blue color substance, as the heat is transforming from high temperature region to the low temperature region, because they are in a physical contact. And after some time, the equilibrium will be achieved, as the temperature difference will be vanished from these particular substances, or we can say that these two substances are at the same temperature, so that we can say that these two substances at a equilibrium condition. Okay, so that is nothing but what, the two substances are in a physical contact and they are exchanging the heat. Two substances are in a physical contact and exchanging heat. That is also called as a conduction heat transfer. That is also called as a conduction heat transfer. Getting everyone? समजतंय सगळ्यांना डेफिनेशन काय आहे कंडक्शनची? समझ रहा है सबको? कंडक्शन की डेफिनेशन क्या है? If you have any doubt, you can ask, you can comment in the chat box. Once again, I will repeat the definition. Now you have two examples. One is related to the heat transfer within a substance, okay, from one part of a substance to another part of a substance, or from one region of a substance to the another region of the same substance. And you have another example, that the heat transfer from one substance to another substance which are in a physical contact, So the definition will be fulfilled in such a manner that conduction is the transfer of a heat from one part of a substance to another part of a substance, or from one substance to another substance in a physical contact with it without appreciable displacement of a molecule forming the substance. Okay, now the meaning of the last sentence or the last some word, that without appreciable displacement of a molecules forming the substance. Now here, whether to transfer the heat from this region to this region, whether the molecules are transferred? No, the molecules are stationary one, they are stationary at there, or they are we can't see the displacement of molecules to transfer the heat. Here also there is no transformation of a molecule from one substance to another substance, so that in conduction we can say that there will not be no appreciable displacement of molecules of that particular substances, So that is the meaning of last few words: without appreciable displacement of a molecules forming the substance, Getting everyone the definition of a conduction and what is meant by conduction? समजतंय सगळ्यांना? Understood everyone what is meant by conduction? Please note down the definition. First, this is the first mode of a conduction. Okay, this is the first mode of a heat transfer. Okay, you can give the heading as a modes of a heat transfer. In that, give the first heading as a conduction. First heading as a conduction. So in that you can write down the definition. Conduction is the transfer of heat. Conduction is the transfer of heat from one part of a substance to another part of same substance to another part of substance part of same substance to another part of same substance or from one substance from one substance to another substance, to another to another substance in physical contact, in physical contact, in physical contact with it, in physical contact with it, in physical contact with it, without appreciable displacement of molecules, without appreciable displacement of molecules, without appreciable displacement of molecules forming the substance, without appreciable displacement of molecules forming the substance, forming the substance. You can draw the simple diagram, okay? So it will be easy to you to understand this particular point, okay? Heat transfer from one part of substance to another part, okay? Heat transfer from one part of substance to another part, okay? Don't show any hand over here, so you will require more time to draw the hand. Show candle, rod, and heat transfer from this region to, or here you can show the arrow that heat flow, okay? Heat flow, heat flow, heat flow arrow, okay? So draw simple diagram. Heat transfer from one part of substance to another part. And always remember one thing, that heat is always transforming from high temperature region to low temperature region. This is the basic thing of heat transfer, okay? Heat is always transforming from high temperature region to low temperature region. Okay, shall we move ahead to the next point? Also, you can draw this heat transfer from one substance to another substance in physical contact. Draw 1D diagram also. You can show the body A and body B, and these two bodies are in physical contact, and it will achieve the equilibrium after some time. Don't go for the 2D figures. Draw for the understanding purpose only. I'm suggesting you to draw this body A, okay, body B, and you can show that the heat transfer by showing the arrow, okay, over here. Heat transfer from this particular orange body to the blue body, okay, and after some time it will achieve the equilibrium, okay? So temperature is equal. So equilibrium condition means what? Thermodynamic equilibrium means what? Two bodies having the similar temperature, and there will not be a existence of a temperature gradient. That will be nothing but a thermodynamic equilibrium, okay? Or shall we move ahead to the next point? Okay, so now we come to know that what is meant by conduction, okay? But how it is happen? Okay, how it is happen? So in solid, the conduction is happening because of a two phenomenon or two mechanism. Okay, the first mechanism is nothing but a lattice vibration. Okay, and the second mechanism is nothing but a transport of a free electron. Okay, there are two mechanisms. Because of that, conduction happen in a substances. First one is lattice vibration, and second one is transport of a free electrons. Okay, transport of a free electrons. Because of that, the conduction happen. Okay, so please note down, in solid the heat is conducted by following two mechanisms. In solid, the heat is conducted by following two mechanisms. In solid, the heat is conducted by following two mechanisms. First one is by lattice vibration, or we can say that molecular vibration also. Lattice means molecular vibration also. Okay, by lattice vibration or molecular vibration also. And second one, by transport of free electrons. By transport of free electrons. By transport of free electrons. Okay, so free electrons are available in metals or non-metals? Obviously it will available in a metals only. So this transport of a free electron will happen in a metals only. Okay, and because of that, the metals are more conductive than the non-metals. Okay, because in metals the free electrons are available to transfer the heat. In metals, free electrons are available to transfer the heat. Whereas in non-metals also, the heat will transfer, but the rate of heat transfer will be very less, because in non-metals, the free electrons are not available to transfer the heat. Only the lattice vibration system will transfer, or lattice vibration mechanism will transfer the heat from one region of a substance to another region of a substance. Okay. So I will clear that particular point about the metals and non-metals. Okay. So how the heat will transfer because of a lattice vibration. Okay. So what will happen? So initially we will consider this particular A number figure. Okay. So it is one substance and which is having the same temperature for all the molecules of that particular substances. Okay. So these are the molecules. Okay. So once we are providing the heat to the one side of that particular substance, so the molecules of that particular side will get heated. Okay, molecules of that particular side will get heated, and they will start vibrating at their mean position. They will start vibrating at their mean position. The position, they will not lose their position, but they will start vibrating at their mean position. And while vibrating, they collide with the adjacent molecules. While vibrating, they collide with the adjacent molecules, and during that particular collision, they transfer the heat to the adjacent molecule. Okay, during the collision, they transfer the heat to the adjacent molecule. In the same manner, the heat will transfer from this molecule to this molecule. So in figure number C, you can see that the heat is transferred to the second column of a molecules. In a similar manner, once the second column molecules will get heated, they will start vibrating at their main position, and they collide with the adjacent molecules, and this phenomenon will be continue at the end of that particular substance. Okay, at the end of that particular substance. Okay, so in figure D, it will be heat will transferred to the column number 3. In figure E, the heat will be transferred to the column number 4, and the further the heat will be transferred to the environment. Okay, further the heat will be transferred to the environment. So lattice vibration means what? Molecules from high temperature region get heated and start vibrating at their mean position and transfer heat to the adjacent molecules by impact or collision, and transfer heat to adjacent molecules by impact or collision. That is nothing but what? The lattice vibration conduction. That is nothing but what? The lattice vibration mechanism of conduction. Okay, so write down first one, by lattice vibration. We have discussed that there are two mechanisms to transfer the heat by conduction. One is lattice vibration and second one is a free electrons. So in that first one, by lattice vibration, by lattice vibration, by lattice vibration, by lattice vibration, in that you can write, in that you can write molecules from high temperature. I forgot one point. Molecules from high temperature region high temperature region get heated. Molecules from high temperature region get heated and start vibrating, and start vibrating, and start vibrating at their mean position, at their mean position, and start vibrating at their mean position, and transfer heat to adjacent molecules, and transfer heat to adjacent molecules, and transfer heat to adjacent molecules by impact. Okay, transfer heat to adjacent molecules by impact. Okay, if you understood, no need to draw the diagram. Okay, if you understood, no need to draw the diagram. Okay, now next is nothing but second type of mechanism, uh, uh, is nothing but by transport of free electron, by transport of free electrons. We everyone knows that the substances or the metals, okay, substances which are having the free electrons called as the metals. Okay, so metals are having the free electrons at their external orbit. Okay, and they can change the orbit also. Okay, once we apply the temperature gradient or the temperature difference between the two surfaces, then the electrons from higher temperature region will start traveling towards the lower temperature region. Okay, the electrons from higher temperature region start traveling to the lower temperature region, which is called as a energy flux. Okay, which is called as a energy flux. Okay, which is called as a energy flux. And these particular electrons carry the heat from one region to another region. These particular electrons carry the heat from one region to another region. Okay, so the transport of free electrons is nothing but free electrons provide an energy flux in the direction of decreasing temperature. Energy flux in the direction of decreasing temperature. For metal, especially good electric conductors, the electronic mechanism is responsible for the major portion of a heat flux. Heat flux means what? The heat transfer rate per unit area, that is nothing but heat flux. We will come to know what is the meaning of this particular term in the upcoming slides. But here you have to remember that the electrons are always transforming from high temperature region to the low temperature region, and while transporting they carry the heat from that particular region to the another region. Okay, because of that metals are good conductor of a heat, because metals having the free electrons, metals are having the free electrons. Okay, whereas in the non-metals there are no free electrons, so they will not uh, um, uh, have this particular mechanism, that is transport of a free electrons. Only the non-metals are having the lattice vibration mechanism of a heat transfer. Okay, lattice vibration heat transfer mechanism. Okay, getting everyone what is meant by transport of free electron mechanism? So in that, write down free electrons provides, free electrons provides, free electrons provides, free electron provides, free electron provides an energy flux free electron provides an energy flux in the direction of decreasing temperature. Free electrons provides an energy flux. Free electrons provides an energy flux in the direction of decreasing temperature. In the direction of decreasing temperature. In the direction of decreasing temperature. Full stop. For metals, especially for metals, especially for metals, especially good electrical conductors, good electrical conductors, good electrical conductors, comma, the electronic mechanism, comma, the electronic mechanism is responsible, electronic mechanism is responsible for the major portion of heat flux, for the major portion of the heat flux. For the major portion of heat flux. Getting everyone? Which are two mechanisms? First one is a by lattice vibration, and second one is by transport of a free electrons. Okay, by transport of a free electrons. Now we have discussed this about the solids. Okay, these two mechanisms we can consider for the solids. Okay, conduction happen in a solid. How conduction happen in a solid? Because of a lattice vibration, and second thing is because of a free electrons. Okay, now how the conduction will happen in a gases and liquids? Okay, simple thing. Okay, it is very much simple in a gases and liquids. Okay, we know that the molecules of a gases and liquids are somewhat apart from each other as compared to the solids. Okay, more apart in a gaseous state, whereas the more closer in a liquid state as compared to gases, more closer in liquid state. We know the kinetic energy theory of a gases. Okay, so once these molecules are the gaseous molecules are randomly moving in the air, and once they are collide with each other, they exchange their energy and movement with the another molecules. Okay, or the collided molecules. So in a similar manner, we have discussed that the conduction will be considered when two substances are in a physical contact. Okay, that will be also conduction. Once these air molecules or the gaseous molecules collide with each other, at that time these two molecules are in a physical contact and they exchange the heat energy with each other. Okay, and they exchange the heat energy with each other. Okay, so as we know that the kinetic energy of a molecule is a function of a temperature. As the temperature increases, the conduction in a gases will also get increases, because the random movement of a molecules also increase because of an increasing temperature, and more molecules collides with each other. Okay, the random movement or the kinetic energy increases, the movement of a molecules, gaseous molecules also get increases, and more collision will happen, and more heat energy will get exchanged because of a conduction. So we come to know that in gases it is very simple, that kinetic energy of a molecule is a function of a temperature. One hot molecule, when it will collide with a cooler molecule, that particular hot molecule will exchange the heat energy with the cooler molecule. Okay, and while collision, they are in a physical contact, so that this heat transfer phenomena will be considered as a conduction phenomena. That heat transfer phenomena will be considered as a conduction phenomena. Whereas in liquids, the similar kind of a phenomenon will happen as like of a gases. Okay, but the molecules of a liquids are very closer to each other. Okay, and the intermolecular force will be exist in between that. Okay, so in liquid also, when the hot molecule of a liquid will collide with the cooler molecule of liquid, then the heat will transfer from hot molecule to the cooler molecule. Okay, from hot molecule to the cooler molecule. Getting everyone? How it will happen in a gases and liquid? Conduction will how happen in a gases and liquid? समजतंय सगळ्यांना? समजतंय? Understood everyone? Okay. So please write down conduction in gases and liquid. 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 In gases, in gases, in gases, the kinetic energy of molecules 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 is a function of temperature, is a function of temperature, is a function of a temperature, full stop. Molecules, molecules are in, molecules are in molecules are in continuous random motion. Molecules are in continuous random motion. Molecules are in continuous random motion, comma, exchanging energy, exchanging energy and momentum, and momentum, exchanging energy and momentum, exchanging energy and momentum, exchanging energy and momentum when molecule from a high temperature region, from a high temperature region collides, molecule from a high temperature region collides with a molecule from the low temperature region, with a molecule from the low temperature region, with a molecule from the low temperature region, comma, it loses heat energy by collisions. It loses heat energy by collision. Full stop. Next point. In liquid, the mechanism in liquid, the mechanism of heat, the mechanism of heat is nearer to that of gases. In liquid, the mechanism of heat is nearer to that of gases, full stop. However, 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 comma, the molecules are the molecules are more closely spaced. However, the molecules are more closely spaced. Molecules are more closely spaced. Okay, getting everyone? Now, most important, the governing law of conduction, which is called as a Fourier's law of heat conduction. Fourier's law of heat conduction. Okay. So now I think we are moving towards the core part of heat transfer. Okay. And this is the basic law on which the complete chapter we can understood. If you understood this particular law, you will understood the complete chapter. Okay. Try to understand this particular law. Okay. So first of all, we have to consider one slab. Okay, this is particular slab, or you can consider wall also. Okay, slab or wall, uh, whose surface area, you can say that this surface area. Okay, this is the surface area. Which surface area we are considering? This surface area we are considering as a capital A, area A. Okay, surface area means what? Height, length. Okay, height, length means what? Multiplication of height and length will be the area. Okay, that will provide you this much surface area. So this particular surface area we are considering as capital A. Okay, and we are considering that this surface, okay, this surface, front side surface. Okay, this side will be considered as a front side. This surface is maintained at a T1 temperature. Okay, this surface is maintained at a T1 temperature, whereas similar kind of surface will be in the opposite side. Okay, similar kind of surface will be in the opposite side, and this surface is having, opposite side surface is having T2 temperature. Okay, opposite side surface is having T2 temperature. Whether it is visible or not, you can zoom it and you can see the diagram. Okay, you can zoom it and you can see the diagram. Okay, so front side surface is maintained at a T1 temperature, whereas the back side surface is maintained at a T2 temperature. And this particular surface area is having surface area capital A. Okay, so T1 temperature, remember one thing, that this temperature, the surface temperature T1 is greater than T2. Okay, T1 is greater than T2. Okay, so one surface is maintained at a T1 temperature which is greater than the another surface which is maintained at a T2 temperature. Okay, so as per our basic rule, that heat is transferred always from higher temperature region to the lower temperature region. Okay, so this Q is nothing but what? Capital Q is nothing but what? The heat transfer rate. Capital Q is nothing but what? The heat transfer rate. Okay, so heat will be transferred from this surface to another side surface. Heat will be transferred from this surface, front side surface, to the back side surface. Okay, heat will be transferred from this front side surface to the back side surface. Okay, so now we have to determine the heat transfer rate. That is nothing but what? The Q we have to determine. Q is nothing but what? The heat transfer rate. Okay, so direction of heat transfer, we will come to know that this is the direction of heat transfer, because the heat is always transforming from the high temperature region to the low temperature region. Here we are considering T1 is the higher temperature and T2 is the lower temperature. Now we have to determine this Q, that is Q is nothing but heat transfer rate. Now for that purpose we have to use the Fourier law of heat conduction. And what it suggests? The Fourier's law suggests us or gives us a statement that the rate of flow of heat through a simple homogeneous solid is directly proportional to the area of the section at right angle to the direction of heat flow and change of temperature with respect to length of the path of the heat flow. Okay, so at the initial stage you will feel that the statement is very much complicated, but we will segregate this statement in a 2 to 3 parts. Okay, first of all we try to understand that rate of flow of heat. Rate of flow of heat means what? Heat transfer rate, simple language. Okay, heat transfer rate through a simple homogeneous solid. Homogeneous solid means what? Having a single phase only. Okay, having a single phase only, and there is no any chemical reaction in that particular substance. Okay, so that will be the homogeneous solid. So the material is having the same composition throughout this particular slab. Okay, so that is nothing but what? Homogeneous solid. Now, which is directly proportional to the area of the section at a right angle to the direction of heat flow. What is the direction of heat flow? This is the direction of heat flow, because the heat is always transforming from high temperature region to the low temperature region. Now we come to know that the direction of heat flow. Now the area which is perpendicular to the direction of heat flow, konta, which area will be there which is perpendicular to this direction of heat flow? Obviously this area. Okay, this is the height and this is the length. Now this area will be perpendicular to the direction of heat flow. This area will be perpendicular to the direction of heat flow. Perpendicular, understood this? Perpendicular area. Okay, so at right angle to the direction of heat flow, area which is at a right angle to the direction of heat flow, and change of a temperature with respect to length. Okay, change of temperature means what? What is the temperature difference between the two surfaces? What is the temperature difference between the two surfaces? So temperature difference between the two surfaces is nothing but what? Always take the next temperature first and the first temperature second. Okay, next temperature is nothing but what? T2. Okay, T2 minus T1 will be nothing but what? Temperature difference. Okay, with respect to length of path of heat flow. Okay, how much length need to travel by this particular heat to reach to the second surface? किती, how much heat, कितना heat, कितना distance travel करना पड़ेगा heat को second surface के surface पर जाने तक? Okay, कितना distance travel करना पड़ेगा heat को second surface तक जाने तक? Okay, so that distance will be nothing but what? The thickness of that particular slab. That distance is nothing but what? The thickness of that particular slab. Okay, getting samajhte hain? How many points included over here? One is nothing but what? The heat transfer rate. Another is nothing but what? The perpendicular surface area. The next is nothing but what? The temperature difference. And the last one is nothing but what? Travel distance by the heat. Okay, that distance traveled by the heat is nothing but what? The thickness of that particular slab. Distance traveled by that particular heat is nothing but what? The distance traveled by this particular the thickness of that particular slab. Now we can say that the rate of flow of heat through a simple homogeneous solid is directly proportional to the area of the section at a right angle. Okay, area of the section at a right angle is nothing but capital A. So Q is directly proportional to, Q is nothing but what? Rate of heat transfer. Q is directly proportional to capital A. A is nothing but what? The perpendicular surface area for the heat transfer. And it is directly proportional to temperature difference with respect to length of path of heat flow. Length of path of heat flow is nothing but the thickness of that particular slab, and temperature difference is nothing but dt. Okay, dt means what? T2 minus T1. T2 minus T1 is nothing but dt. So we can say that Q is directly proportional to A multiplied by dt divided by dx. Q is directly proportional to A multiplied by dt divided by dx. Okay, Q is directly proportional to A multiplied by dt divided by dx. Now here we have to normalize this proportional sign For that purpose, we have to introduce one constant. Okay, proportionality sign will be normalized by a constant. Okay, for that purpose, we have introduced the constant as capital K. Okay, we have introduced the constant as capital K. But while introducing this particular capital K, we have also provided the negative sign. Okay, we have also provided the negative sign. Why we have provided the negative sign over here? Okay, let us understood this particular significance of a negative sign. Okay, always we are saying that the heat is transforming from high temperature to the low temperature. But while taking the difference, we are considering the next temperature minus previous temperature. Next temperature minus previous temperature. Okay, next temperature minus previous temperature. Okay, but the previous temperature is higher than the next temperature. So our difference will be negative. Our difference will be negative. T2 minus T1 will be negative difference. Okay, to normalize this sign, we have provided the negative sign over here. To normalize this sign inside dt sign, okay, dt means what? T2 minus T1, and this will be negative 1 because heat is always transforming from high temperature region to the low temperature region. So we will get this dt as a negative. Now to normalize, we have introduced one more negative sign over here. So q is equal to minus k multiply by a multiply by dt divided by dx, dt divided by dx, where q is heat transfer rate, k is nothing but what? The thermal conductivity of a material. It is called as a constant, and this constant is also called as a thermal conductivity of material. A is nothing but a surface area perpendicular to heat transfer direction. Dt divided by dx is nothing but change in temperature with respect to length, which is also called as a temperature gradient, which is also called as a temperature gradient. Okay, so once we have normalized this equation, we have shifted this capital A on another side, so it will become q divided by capital A, that is heat transfer rate per unit area, will be equal to minus k multiplied by dt divided by dx. So this capital Q divided by small a, that is perpendicular surface area, is called as a heat flux, which is called as a heat flux. Uh, in our language, we can say that we can provide it as symbol as small q. Okay, we can provide it symbol as a small q. Small q means what? Capital Q divided by capital A. Capital Q is heat transfer rate, and capital A is nothing but surface area perpendicular to heat transfer. Surface area perpendicular to heat transfer. Getting everyone the Fourier's law of heat conduction? Getting everyone Fourier's law of heat conduction? Is there any doubt, any question? Here you have to remember that. Okay, this is the homogeneous slab. Okay, homogeneous slab. One surface is maintained at a T1 temperature, which is greater than the another surface temperature. Another surface temperature is T2, which is lower than the T1, which is lower than the T1. So our basic rule of heat transfer is nothing but what? The heat is always transforming from high temperature region to the low temperature region. So here we can say that the heat will transfer from this region to this region, front side surface to the back side surface. So direction of heat transfer will be this. This is the direction of heat transfer. Okay. Now the area which is perpendicular to the heat transfer, that is the perpendicular surface area. So this surface is perpendicular to the heat transfer. Okay. So similar kind of area will be on the back side also. Okay. So this is the area which is perpendicular to the heat transfer. So this is the area. Now we come to know that the heat transfer rate is directly proportional to the perpendicular surface area and the temperature difference with respect to length of path of heat flow and length of perpendicular and the temperature difference with respect to length of path of heat flow. So how much distance need to travel by heat to reach to the another surface. So that distance is nothing but the thickness of that particular slab. This much distance need to travel by heat from to reach to another surface from this surface. Okay, to reach to another surface from this particular surface. So dx is the length which need to travel by the heat to reach to another surface. So according to our law, Fourier's law, we can state that q is directly proportional to capital A multiplied by dt divided by dx. To normalize this proportionality sign, we have to introduce one constant capital K. Here we have introduced the negative sign also, because to accommodate the negative sign of this particular dt, that is the change in temperature. Change in temperature means what? T2 minus T1. Okay, change in temperature is T2 minus T1, but T2 is always less than T1. T2 is always less than T1, so that our difference will be -1. Okay, our difference will be -1, and to normalize this negative sign, we have provided one extra negative sign over here. So q will be equal to minus k multiplied by a multiplied by dt divided by dx. Okay, now we have shifted this capital A on this side, which will give us capital Q divided by capital A, that is nothing but heat transfer rate per unit area will be equal to minus k multiplied by dt divided by dx. Okay, heat transfer per unit area will be called as a heat flux, will be called as a heat flux. Okay, and this capital K is called as a thermal conductivity, whereas dt divided by dx is called as a temperature gradient. Dt divided by dx is called as a temperature gradient. Okay, getting everyone? Any doubt, any question? You can ask the doubt, or you can mention your question in the chat box also. Is there any doubt, any question? Please note down this law. Please note down this particular, draw this diagram, and after drawing diagram, please put up this particular mathematical statements. Fourier's law of heat conduction. Fourier's law of heat conduction. Fourier's law of heat conduction. Statement. The rate of flow of heat. The rate of flow of heat through a simple homogeneous solid. The rate of flow of heat through a simple homogeneous solid. Through a simple homogeneous solid. Through a simple homogeneous solid is directly proportional to the area of the section at right angle to the direction of heat flow, at right angle to the direction of heat flow, at right angle to the direction of heat flow, and change of temperature with respect to length of the path of the heat flow, and change of temperature with respect to length of the path of the heat flow, and change of temperature with respect to length of the path of the heat flow, Okay, so capital Q is nothing but rate of heat flow. Okay, rate of heat flow means capital Q is directly proportional to perpendicular surface area and change in temperature with respect to change in length. Okay, with respect to change in length, or we can say that length of path of heat flow. Okay, so Q is directly proportional to, write down, Q is directly proportional to capital A multiply by dt divided by dx. Capital A multiply by dt divided by dx. Next, we have to normalize this proportional sign. So Q is equal to minus K multiply by capital A minus K multiply by capital A multiply by dt divided by dx. Okay, dt divided by dx. So finally we have to shift this capital A on this side. So we'll get the equation Q divided by A, capital Q divided by A will be equal to minus K multiply by dt divided by dx. Minus K multiply by dt divided by dx. Okay, or where capital Q is equal to rate of heat transfer. Capital Q is equal to rate of heat transfer and its unit is watt. Okay, so in bracket you can write down W, that is the symbol of watt. Capital Q is equal to rate of heat transfer and its unit is watt. Then capital A is equal to heat transfer area. So area unit is meter square. Capital A is equal to heat transfer area and in bracket unit is meter square, and this area is important thing, which area we have to consider, normal to the direction of heat flow. Which is this area? This area is normal to direction of heat flow. Normal means perpendicular to direction of heat flow. So capital A is equal to heat transfer area in bracket meter square is the unit, bracket complete, normal to the direction of heat flow. And I have mentioned over here small q means what? The heat flux. Small q means what? Heat flux. Small q means what? Heat flux. So heat flux means what? Capital Q divided by area. Small q means heat flux and its unit is capital Q divided by area. Okay, small q is equal to capital Q divided by A, which is equal to heat flux, and its unit is watt per meter square. Okay, the next one is dt divided by dx. Okay, dt divided by dx, which is called as a temperature gradient. Okay, change in temperature with respect to length, which is called as a temperature gradient, and its unit is degree Celsius per meter, per meter. Okay, so here my degree Celsius symbol is, I think, wrong. You correct it, degree Celsius per meter. Okay, degree Celsius per meter will be the unit for dt by dx. And the last one, the constant of proportionality K. K is equal to constant of proportionality. K is equal to constant of proportionality. K is equal to constant of proportionality called thermal conductivity. Capital K is called as thermal conductivity, and its unit we will derive in the next lecture. Okay, capital K unit we will derive in the next lecture, and the definition of thermal conductivity of various materials, and how it will vary according to the substance, according to the temperature. Okay, so that we will discuss in the next lecture. Okay, if you have any doubt, you can ask. Revise this particular point when you get the time. So then and then only you will understood the further things. This is the basic law to understood the conduction complete chapter. This is the basic law. If you will not understood this law, you will not understood anything from the chapter. Okay, so this is the basic law. For that purpose I am saying that once again, write down everything, and revise once. If you have any doubt, you can ask now also. You can call me and you can ask also. Okay, I will try to clear your doubt, and I will share this particular lecture on our study material also. Please go and watch that lecture once again, so that you will clear the basic points, and which will help to create a good knowledge in this particular lecture, in this particular subject. Okay, if you have any doubt, you can ask, or else you can put up your roll numbers and you can leave this particular meeting. Okay, I will share the book PDF also. Okay, I will not share in group. I will share on in study material. In study material, I will share that particular PDF of book. Okay, both PDF I will share, PK Nag and RS Agrawal also. Okay, so I think today or tomorrow the study material will be shared with you. So in that you will get that particular PDF, book PDF. Okay, so everyone just put up your roll numbers. I will not be responsible if anyone does not put up their roll numbers in the chat box. It's your responsibility to put up the roll numbers and leave the meeting at required time. Some of the students are still there, and they don't have any attention towards the lectures, and afterward they are saying that, sir, I was present, take my roll number. It will not be considered further. Okay, it's your responsibility to put up your roll number at the end of the lecture. Okay, so we'll stop here, leave this particular meeting. Remaining students just put up roll numbers 35, 31, because I'm referring the chat box only to put up your attendance in roll call list. Okay, so roll number 6, 35, 31. Put up your roll numbers and you can leave the meeting. बोला सर.